area problem. So let's say the rancher has 400 feet of fencing material and he want to create a corral that has three sides, because one side is covered bounded by the barn, so that means you don't need fencing for that side, but you need, so there are three exterior sides, there are three exterior fences and two interior fences. There are two interior fences uh, that partition the corral into three rectangular regions. It doesn't say like whether they are equal or anything like that. They're asking what are the dimensions of the corral that maximize the enclosed area. So again, like when you change the width and length, and you can see that you get different areas. So the question is, for what values of the length and the width you can possibly get the largest area. So this is not like an obvious problem. So you can see selecting different values for width and length, you get very different kind of area. So now the question is, how as a mathematics student help the rancher to find the maximum possible area. So if you get a problem like that, it always like useful to draw a like a figure to express the situation. So let's do that. So we have three exterior sides and one side has a barn. So there are some animals in here. And it also says there are two interior fences. So let's say two interior, so there's a one here and maybe another one there. It doesn't say that they are equal size or anything like that. So you can just draw something like that. So don't make the unnecessary assumptions. Okay, so now that's the situation. So what we can do, we can pick the variables. So let's pick variables, and you can see the width is the common one, most common one. So I'm going to pick x for that. So we can say this is x, and all of them are x. And then the length, I'm going to pick that one as the y. Okay, so now let's write them. So we can say let x equal the width and the y equal the length. So we pick those two. And then what we can do is we can put all those information in there. So the first information what we have is, we know the total length. So the total length, so we can see the total length, which is equals to, so there are four width. So we have 1, 2, 3, 4 width and 1 length. So if you simplify this one, you can write 4x plus y. So that is the total length. And then you know that the total length is equals to, the problem says the total length equals to 400. So this is equal to 400. So this is the constraint equation that we get. From the constraint, we get this equation. And also we know that this both x and y are positive. So x and y, you can say greater than or equal 0. 0 is like a 0 area, but mathematically you can write it like that, not even practical. Okay, so let's say now we can write the objective function, which is the area. So we can say area equal, this is a rectangle, so that means it is the length times the width. So let's substitute here. So if you substitute, you can say length is y, width is x. So it is x times y, and then we can plug in x, because you can see the xy is a two variable function, and you know that you can find maximum minima using two variable function right now. So we're gonna solve for y, and then you can see that from this constraint equation, you can say y equal, if you solve for y, which is 400 minus 4x. So that's what happened for y. That's y equal. So we're gonna plug in that value here. We can say y equal 400 minus 4x. So if you simplify, you're gonna get 400 x minus 4x squared. So that is the objective function. On you can say, so what is the smallest value possible? You can see smallest value possible in mathematically 0. What is the largest value? So you might need to think about the largest value. So how to get the largest value? You can see that those 4x fences. So that means we have there are 4 fences, and when y is getting smaller and smaller, that's the y smallest case. So that means the total. So that means the total is 400. If the total is 400, since there are 4, so the maximum that you can get for x is 100. That's the maximum value. So in this case, y is simply 0. It's not practical, but mathematically you can write like that. So that means it's from 0 to 100. That's where the 100 coming from, because there are 4 interior ones and then 4 widths. So we said that equal to one of them equal to 100. Okay, so we get that. Now what we can do is, so we know the problem now. So what we want to do simply is maximize. So we're going to say maximize. I'm going to call the area function. You can say a. That is a one variable function now. So it's ax, which is 400 x minus 4x squared on the interval 0 to 100. So that's the actual problem. So we can use calculus to do this right now. So let's do that. We are going to maximize a on the given intervals. What we now do in calculus is we're going to find the critical points, because we know that at the critical points you're going to get the maximum or minimum value. So for the critical points, what we can do, we can look at the derivative. So the derivative of this function is easy to find, which is 400 minus 8x. Now what we can set this one equal to 0. And once you set this one equal to 0, you can see that you can get 8x equal 400. If we divide both sides by 8, so you're going to get 50. So x equal 50 as the only critical point. So only critical point means that since there are no other critical points, so the absolute maximum or minimum should actually, I mean, it can be because there are endpoints. So in endpoints, normally what happens is you get the minimum value. At the critical points, you're going to get the maximum value. So that means, so what you can write this statement actually. You can say, only one critical points implies that the absolute maximum should happen at this point. Okay, so absolute maximum or minimum occurs at this point. So the thing is that, so it's not local minimum, because we are looking for the absolute maximum. So it's happened at the critical point. Now what we can do, we can use a secondary test to check what kind of maxima we have here. So for that we can use a second test. So use second derivative test. So the second derivative for this one is easy to find. The second derivative is -8. This is true for any x. So that means even for the critical point, what we do is you have to evaluate at the critical point. So the critical point is 50. So even at 50, you get -8, which is negative. So by the second derivative, it says that second derivative negative means has a maximum. So has a maximum, but we know that that should be the absolute maximum then. So there's an absolute maximum at, there is a absolute maximum at x equal 50. Now what we're going to do is we're going to find the corresponding y value, and then once you find the corresponding y value, you can actually find the maximum area now, because we know that that happened at 50. So the corresponding y value, so let's try to find it. We know that y equal 400 minus 4x. So the corresponding y, so y equal, we know that 400 minus 4x. So if you plug in that, which is 400 minus 4 times 50, which is 200. So you get 200. So 200 is the y value. Now we know that when width is 50 and the length is 200, you're going to get the largest possible area. So we can also find the largest possible area, because since we know the length and the width, just multiply the two numbers and you get the largest possible area. So you can say like this. So largest area equality is length time width. So if you multiply the two numbers, you're going to get 200 feet times 50. So that means you're going to get 10,000 feet squared as the largest possible area. So the dimension of the corral is the dimension of the corral that maximize the area is you can say 200 times, so 200 feet times 50 feet. So we can write the answer like that at the end. Okay, so that's how you solve the maximum area problem. That means when the width is 50 and the length is 200, you get the maximum possible area of the barn. So area of the corral. So that's the situation where this side is 50 feet and this side is 200 feet. So when you do that, and you can see according to the mathematics we did, you get the largest possible area. So this is how you use the mathematics to solve a problem like that.